Okay, question 8. Okay. So, Mrs. Mills buys 4 packs of treats for her cats, Fluff and Tigger. She gives Fluff 1/6 of a packet each day. She gives Tigger 1/5 of a pack each day. For how many complete days will 4 packs of treats last? Well, first of all, let's see what fraction Fluff and Tigger, when put together, what fraction of a packet Fluff and Tigger eat in a day. 1/6 plus 1/5. Well, we need to have a common denominator. That's going to be 30. So we're going to be doing 5/30ths plus 6/30ths, which is 11/30ths. So that's 1 day. Okay. 4 packs is the equivalent to 120/30ths. Okay, so that's basically 30 times 4 for our numerator. So if we then take our packs and divide it by how much is eaten in a day, that's 120/30ths divided by 11/30ths. We're going to use keep flip change, or our reciprocal of 11/30ths, to turn it into a multiplication. To multiply these two fractions together and simplify them is really easy, because there is a common factor of 30 in the numerator and the denominator. So it'll be 120 over 11. So basically we've got to do 120 divided by 11. Well, that's going to be so 11, can't share any hundreds between 11. 12 tens shares once with a remainder of 1, so we'll exchange that for 10 ones, and that's not going to work. There will be a remainder, but it's going to be 10 days, 10 whole days. Okay? Can't be any more than that. Okay, angles. An interior angle of an isosceles triangle is p degrees, and the exterior angle is q degrees. It is given that q equals 5p. What is the ratio of p to q in its simplest form? 1 to 5. Work out the different possible sets of angles for the isosceles triangles. Okay, so there are, P is the interior angle of the isosceles triangle. So what we could have is one where we've got 2 angles here that are both the same. So the other alternative is where so basically these 2 sides are the same length as each other. The other alternative is where we've got a triangle where these 2 sides are the same length and these are different. Okay. We need to work out what the size of P is as well. So we know that angles on a straight line are 180, and we've been sharing in the ratio 1 to 5. So 1 plus 5 equals 6. 180 divided by 6 equals 30. So P equals 30 degrees. That means that we could have a triangle which is 30, 30, and the other angle must be 180, take away those 2 30s, 120. Then our other alternative is 30, and then the rest of it shared. So 180 take away 30 is 150. And then these 2 angles will both be the same, so we'll do 150 divided by 2, 75. So our other triangle is 30, 75, 75. Question 10. Write 1/6 as a reoccurring decimal. We might need more zeros, but I'll just start there. Can't share 1 between 6, so we'll exchange that 1 whole for 10 tenths. Each person could get 1 tenth, and there'll be 4 tenths left over, so we'll exchange those for 40 hundredths. We can share 40 hundredths between 6 people, and we can do that 6 times with a remainder of 4, so we'll exchange those well, this will keep on happening. It's going to be 0.16 and the 6 reoccurs. If you don't believe me, you could have done it a few more times. 40 divided by 6 is 6, remainder 4. Just okay, now Elsa divides a 2-digit number by another 2-digit number. She gets the answer 0.15 reoccurring. The 5 reoccurs, the 1 does not. She says there is only one possible pair of numbers that will give this answer. Is she correct? Show how you decide. Well, I'm going to say that x equals 0.15. What I'm going to do is I'm going to turn this into a fraction. To do that, I'm going to multiply by 10, which means that 10x equals 1.5 reoccurring. I need another, these two numbers don't have the same thing after the decimal point, so I need two numbers which have exactly the same thing after the decimal point, so that when I subtract one from the other, which is what I'm going to end up doing, everything after the decimal point will disappear because they'll be the same as each other. So 100x is going to be 15.5 reoccurring. Oops. At this point, I can go, okay, well if I do 100x, take away 10x, I'm doing 15.5 reoccurring minus 1.5 reoccurring, which means that 90x is going to equal 14. Which means that x is 14 over 90. We could have done 14 divided by 90 and got the answer 0.15 reoccurring. They are two-digit numbers. If we think about what the other fractions that are equivalent to 14/90ths are, they will be other pairs of numbers that will divide to make 0.15 reoccurring. So the smaller fraction will be 7/45ths, and the next larger one would be 21/135ths. So she is correct. Only 14 divided by 90 will do it. Okay, 11a, simplify fully, root 200. Well, I'm going to look for factors. I want one of them to be a square factor. 100 is a square number, and therefore the other one must be root 2. That means that we can square root 100 and get 10, but we cannot square root 2, so we're left with 10 root 2. And then part B says, evaluate 8 to the power of a third. 8 to the power of the third is the same as doing the cubed root of 8. So a number that we have to times by itself 3 times and gets an answer of 8 is 2. Okay. Here are two functions. Function A is times by 3 take away 2. Function B is plus 7 times 2. Find an algebraic expression for the output of the inverse of function A when x is put in. So we're going to be going the other way through function A, and we're going to pop x in, and we're going to see what comes out. So because we're doing the inverse, everything is opposite. We're going the opposite way through, and we're doing the opposite thing. Plus 2 divided by 3, which means we are doing x plus 2 and dividing all of that by 3. Here is a composite function c. Function c is x goes into function a, and the result of function a goes into function b to give us z. And we are told that z is 4x. Find the value of x. Okay, so first of all, let's see what happens when we pop something into function a. We're going to times it by 3, so that'll be 3x. We're going to take away 2. So once we go into function a, we've got 3x minus 2. Now that's going to go into function b. The first thing that we're going to do when it goes into function b is add on 7. And then we are going to multiply everything by 2. And we are told that that will equal 4x. Because z equals 4x. I'm going to multiply out and simplify this. We'll simplify inside the brackets first of all. So we'd end up with 3x plus 5 inside the brackets. Then if we multiply out the brackets, we get 6x plus 10 equals 4x. And then if we get the x's set all on one side, we'll get 2x plus 10 equals 0. Then the 2x's by themselves, 2x equals minus 10, so x equals minus 5. Question 13. Shirley is asked to sketch a graph for y equals 5 to the power of x. For x is greater than or equal to 0. She produces the following. The graph has 2 errors. How should they be corrected? So I'm going to draw one for you that is correct. This is an exponential graph. Exponentials cross the y-axis at 1. That is her first mistake. Hers goes through the origin. And they get steeper and steeper and steeper, so they curve upwards. Okay. So it should cross the y-axis at 1, and it should curve upwards. And the upwards bit is important. You shouldn't say it, just saying it should curve is not good enough. And in the diagram, AB is parallel to CD, AED and BEC are straight lines. Prove that ABE is similar to CDE. So if it's similar, the angles will be the same. Sides. So these two angles will need to be the same. We can say that AEB is equal to DEC. They are vertically opposite. Okay. Some more angles that should be the same. This angle should be the same as this angle, and they are because BAE is equal to EDC. They are alternate. And then we need to prove that the other two angles here and here are the same. We could use angles in a triangle, or we could observe that they are both alternate again. So we've got ABE is equal to DCE, they are alternate. And these two triangles are similar. Side, side, side. No, angle, angle, angle.